Time for another acronym. For this one, all you really need to know about in advance is everything on multiples. That's in video M006. However, if you've got a grounding in everything else that's happened in this unit so far, that can't hurt either. So we've already said that the multiple is the ugly big brother of the factor, and with that in mind it should be fairly easy to get your head around what the LCM is, given that the HCF is the highest common factor. LCM, the lowest common multiple. It is the smallest number that is in the times tables for two or more other specific numbers. As an example then, what is the lowest common multiple of 3 and 5? In other words, what is the smallest number in both the 3 and 5 times tables? If you know that straight off the bat, absolutely fantastic times table knowledge, well done. However, if you don't, here's how we get there. We're going to lay out the times tables for both of these numbers, and when we find a match, we'll know that that is the smallest number in both lists. So we have 3 and 5. So times them both by 1, 3 and 5, by 2, 6 and 10, by 3, 9 and 15, we then have 12 and 20, 15 and 25. A match. 15 is in both lists. 15 must be the lowest common multiple. It's quite an easy method for numbers with fairly low lowest common multiples. Have a go at using it with these. Pause the video and restart once you have your answers. For question A, we have 8 and 12, 16 and 24, 24 and 36. And 24 has come up twice, so it must be the lowest common multiple. For B, we have 6 and 4, 12 and 8, 18 and 12. Now we've already had 12, so 12 is the lowest common multiple. And finally for C, we have 5 and 6, 10 and 12, 15 and 18, 20 and 24, 25 and 30, 30 and 36. And that's a match for 30, so 30 is the lowest common multiple. You'll notice that 30 is 5 times 6, which in this case is the two numbers we were looking for times together. And when you do this, you won't always get the lowest common multiple, but you can guarantee it will be a common multiple, which might be helpful in some situations. Now you have the concept of the lowest common multiple down, we want to be able to find this for numbers that are really complicated, numbers where finding the times tables for them would be incredibly impractical. And in order to do that, we're going to have to use, you guessed it, numbers written as the product of primes.